So I will read the problem statement and extract the given data. A cam is to give the following motion to a knife edge follower. So I have written here the follower is knife edge. To raise the follower through 30 millimeters with uniform acceleration and retardation during 120-degree cam rotation. So theta O is the angle turned by the cam during outstroke, that is when the follower is rising, and the follower raised through 30 millimeters, that means lift or stroke of the follower indicated by S is 30, and the motion during outstroke is uniform acceleration and retardation. There is dwell for next 30 degrees of cam rotation. So dwell angle theta d is equals to 30 after the rise of follower. Then to lower the follower with simple harmonic motion during the next 90-degree rotation of the cam. Now return stroke angle is 90 degrees, so theta r is equals to 90, and the motion of the follower during return stroke is SHM. Okay. Now there is dwell for the rest of the cam rotation. The cam has a minimum radius of 30 millimeters. So RB, which is the minimum radius of the cam or base circle radius of cam, is equals to 30 millimeters. And cam rotates counterclockwise. So cam rotation is counterclockwise. We have to draw the profile of the cam when line of stroke of the follower passes through the axis of cam. That means follower is radial follower. So radial knife edge follower, stroke is 30 millimeters, outstroke angle is 120 degrees with uniform acceleration and retardation. Dwell period is of 30 degrees between outstroke and return stroke. Return stroke is 90 degrees with simple harmonic motion. Base circle radius of cam is 30 millimeters and cam rotates counterclockwise. So first of all, we will draw the displacement diagram of the follower. On y-axis, we plot the stroke of follower, which is 30 millimeters. So I will use scale of 1:1. I will plot the stroke on y-axis of 30 millimeters. Now I will draw one parallel line to x-axis from this stroke. Okay. So this is the stroke line. Now first stroke is outstroke of 120 degrees. So on x-axis, I will take scale of 1 centimeter is equals to 20 degrees for outstroke. So 6 centimeter will be 120 degrees. So here is my outstroke. So this is outstroke. Next is dwell of 30 degrees. For dwell period, I will take scale of 1 centimeter is equals to 10 degrees. So for 30 degrees, I get 3 centimeters. So this is dwell period of 30 degrees. Next, return stroke is of 90 degrees. So for a return stroke, I will take scale of 1 centimeter equals to 15 degrees. So 6 centimeter will give 90 degrees. So this is my return stroke. Now in the next step, let us divide the outstroke angle into 6 equal parts. So I have 6 centimeters, so one division is of 1 centimeter. So 1, 2, 3, 4, 5 and 6. Similarly, I will divide the outstroke into 6 equal parts. So one division is of 1 centimeters. I will draw the vertical lines through these divisions. Through all the divisions, you need to draw the vertical lines. I have divided outstroke and return stroke into 6 equal parts. You can divide it into any even number of equal parts. Okay, 4, 6, 8, 10, 12. Also, you can divide outstroke and return stroke angles with different number of divisions, and you can use different scales for outstroke dwell as well as return stroke. Now I will number those divisions. So 0, there is my 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, 11 and 12. So I have numbered the divisions. Now this is outstroke angle theta O. Next is dwell period of 30 degrees, and this is return stroke of 90 degrees. Okay. Now during outstroke, the motion is uniform acceleration and retardation, and the follower is rising. So we'll assume that during first half of the stroke there is acceleration, and during second half of the stroke there is retardation. Okay. So let us divide the center line of the stroke, line number 3, because we assume that during half of the stroke there is acceleration, and during next half of the outstroke there is retardation. So I choose the midline, that is line number 3, and divide it into same number of parts as that of the outstroke. I have divided the outstroke into 6 equal parts, so I will divide line number 3 into 6 equal parts. So line number 3 is 35, so I have by mistake taken the stroke as 35, so I will change the value here to 35. So 35 divided by 6 is 5.8 millimeters approximately. So 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5, and this is 6. Now I will number these divisions from bottom to top, because this is outstroke, follower is rising. So this is my 1, 2, 3, 4, 5 and 6. Okay. Now we'll draw the projection lines from this side, because this is the outstroke, follower is rising. So we'll join this origin to point number 1 on line number 3. And now this line, which is joining point 1, will cut the division line number 1 at 1 dash. So intersection of 1, 1 will give 1 dash. Now I will join origin to point number 2. Now this line joining 2 will intersect the division line number 2 at 2 dash. Okay. Now we'll join number 3. This line will intersect the division line number 3 at 3 dash. Now I will draw a smooth freehand curve passing through these points 1 dash, 2 dash and 3 dash. This is the displacement curve or displacement diagram of the follower during first half of the outstroke when there is acceleration. Now for second half of the outstroke there is retardation. So I will join this diagonal point, which is diagonally opposite to origin, to point number 3. This will intersect 3 at 3 dash. We will join this point to 4. So this line joining this point to point number 4 will intersect the division number 4 line at 4 dash. Now I will join this. Now this line joining point 5 will intersect the division number line 5 at 5 dash, and 6 will intersect at 6 dash. Now I will extend this freehand curve through these points up to 6 dash. This is the displacement diagram of the follower during second half of the outstroke, during which follower is retarding. Now for next 30 degrees there is dwell, so follower will have zero displacement. That means we will get a straight line for zero displacement. So this is displacement curve during the dwell period, straight horizontal line. Now during return stroke, the follower is moving with simple harmonic motion. So we need to draw a semi-harmonic circle on this side with diameter equals to stroke. So stroke is 35 millimeters. So radius will be 17.5. So this is the center point. We'll draw the semi-harmonic circle using a rounder with the stroke length as the diameter. Okay, so this is my semi-harmonic circle. Having diameter equals to stroke, this is the center of circle. Now we will divide this semi-harmonic circle into same number of part as that of the return stroke angle. We have divided return stroke angle into 6 equal parts. So let us divide this semi-harmonic circle into 6 equal parts. Okay. So 180 divided by 6. 30. So each division will be of 30 degrees. Place the protractor here. First division 30, next is 60, next is 90, then this 60 on the opposite side, 30. Now we will join these divisions to the center of the semi-harmonic circle using straight lines. So this is first, this is second, this is 90 degrees, fourth one, and this is fifth one. Now let us number these divisions on semi-harmonic circle. We will number from top to the bottom because the follower is returning to the lowermost position. So I will number from top. This is 6, 7, 8, 9, 10, 11, and this is 12. Okay. Now let us project these divisions on semi-harmonic circle over the divisions of the outstroke, vertical divisions on the outstroke, using horizontal lines. So 6 will intersect 6 at 6 dash. Now 7 will intersect 7 at 7 dash. So projection line coming from point number 8 or division number 8 on the semi-harmonic circle will intersect the division line number 8 of the return stroke at 8 dash. Similarly 9 to 9 dash, 10 to 10 dash, 10 will intersect 10 at 10 dash, 11 will intersect 11 at 11 dash, and 12 at 12 dash. Now let us draw a smooth freehand curve passing through these intersecting points. This is the displacement diagram of the follower during return stroke when the follower is returning with simple harmonic motion. Now from this displacement diagram we will draw the cam profile. The base circle radius is 30 millimeters. So first of all we'll draw the base circle having radius of 30 millimeters. For drawing the base circle, we have to take the same scale as that of the y-axis in the displacement diagram. For y-axis in the displacement diagram, we have taken scale of 1:1. So for base circle, I am taking the same scale, radius of 30 millimeters. So this is my circle having radius of 30 millimeters. This will be the base circle. I will color it for you so that it is visible more clearly. So this is the base circle whose center is the center of cam rotation, base circle radius of 30 millimeters. Then in the next step we have to draw the prime circle, but since the follower is radial follower or knife edge follower, prime circle will coincide with the base circle. The type of follower is knife edge follower, radial follower. So I will show the position of the follower on the vertical axis. You can show it on any one of the axes. So this is knife edge follower whose line of action, whose axis is passing through the camshaft center. Because the follower is radial. Now in the next step, we will divide this base circle into equal number of parts as that of the x-axis in the displacement diagram. You just imagine that the length of this x-axis is equals to the length of this circumference of the base circle. So we have divided the x-axis into outstroke, dwell and then return stroke. Now we will divide this. For that we have to take into consideration the direction of rotation of the cam. Direction of rotation is given as counterclockwise. So I will show it here. Cam is rotating counterclockwise. So we have to divide this circle in opposite sense, that is clockwise sense. First division is of 120 degrees. The reference to start the divisions will be the line joining trace point to the cam center. This is the trace point of the follower 0 and this is the cam center O. From this, the first angle is 120 degrees, which is outstroke angle. So this is 90, 100, 110, 120. So this is my outstroke angle theta O. Remember, if I have to divide these in the opposite direction of rotation of the cam. Cam is rotating counterclockwise, so we are dividing in clockwise direction. Next is dwell of 30 degrees. From this line, it is 30 degrees. Place the protector. This is 30 degrees. Dwell period. Theta D. Next is 90 degrees. 90 degrees of return stroke. So here is the 90 degree, the end of return stroke. So this is theta r, and rest of the period is dual. Okay. Now after this, we have divided the outstroke angle into 6 equal parts. So here we will divide the outstroke angle into same number of parts, that is 6 equal parts. So 120 divided by 6, or you can also divide the circumference, is 20 degrees each division. So 1, 40, 60, 80, 100 and 120. So 1, 2, 3, 4, 5 and 6. So I will draw the radial lines passing through these divisions. 1, 2, this is 3, this is 4, and this one is 5. I will number the divisions starting from 0 trace point. So this is 1, 2, 3, 4, 5, and this is 6. End of the outstroke. This is also 6, dwell period. Now we have divided the return stroke angle into 6 equal parts. So here also we will divide the return stroke angle into 6 equal parts. So 90 divided by 6 is 15. So 15 degree each. $15, $30, $45, $60, $75 and $90. Draw the radial lines passing through these divisions on the prime circle or base circle. 1, 2, 3, 4 and 5. I will number the divisions: 7, 8, 9, 10, 11 and 12. Now these are the line of action of the followers at these instances. Instance number 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, 11, 12. Now we will plot the displacement of the follower at all these instances from the displacement diagram. We start from point number 1. This is 1. This is 1. So this distance 1, 1 dash is the displacement of the follower when the follower is at point 1. So it is 2 millimeters. So this is 2 millimeters in radially outward direction from the base circle or prime circle. Okay. So this is my 1 dash, 1, 1 dash from displacement diagram. Similarly, at point 2, displacement of follower is 6 millimeters. 2, 2 dash is 6 millimeters. So this is 2 dash. At instance 3, displacement is 27, sorry, it is 16, it is 16, and this is my 3 dash. Now at 4, the displacement is 4 to 4 dash. So 4 to 4 dash. This is 4 dash. At the instance number 5, displacement is 5 to 5 dash. So 5 to 5 dash. And at instance number 6, displacement is 6 to 6 dash. 6 to 6 dash. We will continue with the written stroke. So 6 to 6 dash. Next, 7 to 7 dash is the displacement of the follower at this instance. So 7 to 7 dash. Now 8 to 8 dash, displacement at this instance. 9 to 9 dash, we will plot all the displacements from the displacement diagram. Now we will make use of scale. 10 to 10 dash is 9 millimeters. And 11 to 11 dash is 4 millimeters. And 12 dash will coincide. Now in the last step we will draw a smooth freehand curve passing through these points, because these are the positions of the trace point as the follower rotates in opposite direction of the cam rotation over the surface of cam. Okay. So start from 0, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. 6 dash to 6 dash is the dwell period, means that must be a circular arc. Dwell period, in the portion of the dwell period, the cam surface is always circular arc with center at the cam rotation. So this is the required cam profile. We will continue this because this is the last dwell during which the cam profile is circular arc with center at the cam rotation. So this is the required cam profile for the knife edge follower.